Okay, for A, we need to find the derivative of 3 to the x squared plus 2x plus 5. For that, we need to use the formula of a to the u. So derivative of a to the u is going to be a to the u times ln of a times du. So we need to find a, u, and du. So a is 3, u is x squared plus 2x plus 5, and du would be 2x plus 2. So the derivative is going to be 3 to the x squared plus 2x plus 5 times ln of 3 times the derivative of u. For b, we need to use the derivative of ln of u. It's going to be 1 over u times du. So u is x squared plus 1. The derivative of u is 2x. So my derivative is going to be 1 over x squared plus 1 times 2x, or 2x over x squared plus 1. For c, we need to use that the derivative of log base a of u is 1 over u ln of a times du. So a is 10, u is cosine of x, so du is going to be negative sine of x. So my derivative would be 1 over cosine times ln of 10 times negative sine of x, or 1 over negative sine of x over cosine of x times ln of 10. Now, sine of over cosine, okay, we can use our trig identity. Sine of x over cosine of x is tangent of x. So I can rewrite this as negative tangent of x over ln of 10. Okay. For number 2, we need to find the inverse at 3 and the derivative of the inverse of 3. So if we're talking about the inverse, 3 is my y value. Okay. So in order to find my x value, I need to set that equal to 3. So what we're going to do is we're going to use our calculator. We're going to graph 1/4 x cubed plus x minus 1. Okay, so there's the graph. And what we're going to do is we're going to use our table. So if you go into second table, here's your table. So you want the y value of 3. So you're trying to find the x. So x is equal to 2. Okay. So part A, what's the value of the inverse at 3? Equal to 2. Part B, in order to find the derivative of the inverse at 3, first thing we're going to do is find the derivative of my original function, which is 3/4 x squared plus 1. We're going to find the derivative at 2, my x value. So I'm going to get 3 plus 1, or 4. Okay, so the derivative of the inverse at the y value, it's going to be the reciprocal. So 1 over 4. Okay, for 3, I need to find the derivative at 0. So once again, I'm going to use the formula. The derivative of ln of u is 1 over u times du. So u is x plus 4 plus e to the negative 3. Du is going to be 1 plus 0 plus negative 3 e to the negative 3x. Okay, remember the derivative of e to the u is e to the u times du. Okay, so my derivative is going to be 1 over x plus 4 plus e to the negative 3x times du. So then we're going to substitute 0. So wherever I see an x, I'm going to go ahead and substitute 0. So my derivative is going to be 1 minus 3, because e to the 0 is 1, times 4 plus 1, so again, e to the 0 is 1. So I get negative 2 over 5. Okay, so find the derivative of tangent of 2x for pi over 6. So the derivative of tangent is secant squared times the derivative of the inside. So we're going to substitute pi over 6 for x. So we get 2 secant squared of pi over 3. Okay, so now we need to find what secant squared of pi over 3. Well, secant, I can rewrite it as cosine, 1 over cosine. So secant squared of pi over 3 is 1 over cosine squared of pi over 3. And cosine of pi over 3 would be 1/2. We need to square that. So we get 2 over 1/4, which is 2 times 4 over 1. And we get 8. Okay, so now we need to find the second derivative. So my first derivative is going to be negative sine of x plus secant squared of x. My second derivative is going to be negative cosine of x plus, okay, so secant squared of x is the same thing as secant of x squared. Okay, so we're going to use the chain rule. So the derivative here is going to be 2. Everything on the inside stays the same, subtract 1, times the derivative of the inside. And the derivative of secant of x is secant of x times tangent of x. So we're going to have secant squared x times tangent of x. Okay, for number 6, it's for values of h very close to 0, which of the following function best approximate f of x? So basically what it's asking is, what is the limit as h goes to 0 of secant of x plus h minus secant of x over h? So this is basically the definition of the derivative. The definition of the derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. So I need to find what f of x is. So f of x is going to be secant x. So what this means is find the derivative. So the derivative of secant of x is secant of x times tangent of x. There would be my values. Okay, so we need to find the derivative. So I'm going to rewrite this as 8, 3x plus 8 to the negative 3. I'm not going to use the quotient rule because 8 is a coefficient. So I can just go ahead and use the chain rule. So my derivative is going to be negative 24, 3x plus 8. Everything on the inside stays the same. Subtract 1 times the derivative of the inside. So that's going to be negative 72 over 3x plus 8 to the fourth power. Okay, so find the derivative. So once again, we're going to rewrite this as x squared minus x plus 10 to the 1/2. So the derivative is going to use the chain rule. So 1/2 x squared minus x plus 10, subtract 1, times the derivative of the inside. So we're going to have 2x minus 1 over 2 square root of x squared minus x plus 10.